Good afternoon. Welcome back to another quick video about using SolidWorks for beginners or for the basics. Last time we created this oddball block just to play with making some features. You can see that we made it with I would consider to be almost minimal features. Boss extrude, a boss, some fill and chamfer, some cuts and so forth, and then mirrored everything over, so it keeps our feature tree rather short. So now the question is making a drawing for it. Okay, so I've already opened up my drawing sheet. Okay, and I want to insert my part. Okay, um, by default I want to show my hidden lines. And we'll just place the first view and decide is that what we want for our front view. Okay. Remember, your main view is your front view. Doesn't matter what it's called in the model. It could have been any of the views, but if I escape and I hit this again, it gives me the standard views again. It could be anything we could choose to be our front view, but this is a good one. Okay, so we kind of thought about that in the creation of the part. Okay, so we show our hidden lines, we remove our tangent edges on our multi-views. Okay, multi-views being front, top, right, left, back, bottom. Okay, so let's get our good views here first. So we've got front view. Now we will project. Okay, we'll project a right, we'll project a top. We'll go ahead and project an isometric. That's the that's a very common layout. Okay. It's not every drawing, but it's very common. Okay. Your isometric doesn't typically show hidden lines, tangent edges. With a right click, you can go to tangent edge and you can show that with a font. And you can even play this one. Again, you can customize the scale without getting in trouble. So we could say whatever we want to make it to be 1 to 4, 1 to 3, whatever. We just want to get it out of the way. As long as it's big enough to see, and it's not going to be scaled. It's not going to be, I mean, physically scaled. It won't be, there'll be no dimensions on it. So it's just a picture. Okay. So um, let's see. Um, Pause just a sec here. All right. So we've got our views. Let's make sure our tangent edges are shown properly. So we'll right click, tangent edges removed. Okay, tangent edges. Are we sure tangent edges are? Yep, tangent edges removed. Okay, good, good, good. Sorry about all the mumbling. It's just kind of habit that happens when you try to help people with how to do things as much as I do. So now, if I notice that I've already saved the drawing to the same name as the part, um, this stuff comes in from the file properties of the sheet or the drawing. And the other stuff is supposed to come from the part. So if I hit rebuild, okay, the other stuff, material, finish, weight, title, came from the file properties of the part. All right, now we can start thinking about how would we detail this thing out. Okay, well, we know we want it to be a symmetric part. We are not trying to select a datum off of one end or the other. We want this thing to be symmetric. So keeping that in mind, as we dimension, we're always going to dimension our to and from. I like to start with my overall sizes as if I can and work my way down. So I look at this as a cut. Okay, so depth of that cut or the length of the protrusion, whichever way you want to look at it. Um, what is important? Is it the width of these or is it the cut? Okay, so being that it looks like it's supposed to fit down in some grooves or something, I'm going to say, you know what, the spacing between these is probably critical, and maybe the width of them. Okay, and in that case, I highlight all three of those holding the control key, I'll make them all 3 decimal places for plus or minus 5 thousandths based on our tolerance block. Okay, that became a little messy, so I'm going to move that, stagger those down a little bit. All right, now, if the part is to be symmetric, I don't necessarily have to dimension everything. If I put a center line in it, it'll be duplicating actually if I was to put this dimension over there as well. So let's do the center line. So if we, again in the annotation tab, center line, we choose the outside edges and it places a center line. We might want to stretch that a little bit. All right, and then we want to call it out as a center line. We'll use a note. We'll notate it to be a center line with a center line symbol. Add a symbol, center line, come in here, and I'm just going to make sure that when I drop it off, I am inside of that view block. If you drop it off inside the view block, it travels with. If I had placed it out here anywhere else and then moved it in, it would not move with. Okay. All right, so we've established the width is 2 inches, the width of this 1 1/4. That means this one will be 1 1/4. The depth 3/4 of an inch counts for all those cuts all the way across. I think that's no problem. We want to be absolutely certain. We could dimension from here to there. That way our extension line extends all the way over to that edge. Okay. What else do we have in this view? We have a hole to call out and to locate. Okay, so there's a call out. Now, what is our baseline here? I believe that this thing's going to set down on something. I'm thinking that this surface is our baseline, but I don't know. Really depends on the part. If the part was meant for this surface to be what it bottoms out against, then that would be our datum. If this is the edge that it would bottom out on, that would be our datum. Let's assume it's this one. Okay, so assuming it's this one, there's our dimension for locating that hole. It's getting a little crowded over here, huh? All right. Well, I don't care much for jumping back and forth, but we can if it's necessary for clarity. So we'll dimension from here to there because that's the same edge. We will assume that that location is important, so we'll put a 3 decimal place dimension on that. And we will, let's see. What else do we need to, oh, the whole call out got deleted. All right, so there we go. Whole call out. This might be a good case for a special tolerance, just because you see a hole like this, you might assume that there's a shaft being pressed into it, or maybe it needs to be a tight slip fit. Who knows? So let's just practice here. We'll practice putting a bilateral tolerance on it, for example, and say we want to make sure the shaft will go in, but it's going to be pretty close. So we'll say +5 minus nothing. How about that? Okay. And I really like that location for that, but it's kind of jumbled up with this 6. We could move the 6 down here, or we could just move it to the other view. Let's just move it to the other view. Okay. All right. All right, so we've got length, we've got height, we've got the cuts. we've got to get the little details now. So we need to get this radius, for example. Try that again. Uh, there we go. That's what I wanted to see. And I can flip my arrow by clicking that little point on the back of the arrowhead. And I can show 3 decimal places just because it's such a small number. And there's going to be 1, 2, 3, 4 of those. So 4x. Okay. And then we have chamfers as well. So under smart dimension, we go down here to the bottom, we have chamfer dimension. If it's nothing but a chamfer, it's not like a critical angle that we really need to give more extra detail to. It's just a chamfer for a lead in or even just for knocking off a sharp edge. Then what's the difference? We place that there. We say it's a 1/8 inch chamfer at a 45-degree angle. And same thing, we will say there's 4 of those. Okay. All right. Nice. That looks pretty neat. Pretty neat. All right. We located the hole. It's on the center. Symmetric, symmetric, symmetric. I think we're okay. Okay. Never know. I might miss something too. All right. Let's go to the top view, shall we? Top view. First thing I see, the only thing I see really, I see these holes. So, hole call out. Call out that hole. Bam. There's everything I need to know about that hole. Need to locate them. Okay, so locating the holes. Again, I started to do it from the edge, but this part's all about symmetry, right? Why don't we do a center line? Yes. Note our center line. Again, I was make sure I place that inside that view. So it'll move together. And now we can just dimension the spacing of those holes because they are to be symmetric. 3 decimal places for hole locations just to make sure they line up with whatever it is they're lining up with. All right. Making sure that nothing crosses over the borders. I don't want anything touching my borders. All right. Let's see. We didn't get a distance across here, but it's also on a center line. So let's just get the center line again. Done. This would have been more efficient done it all at the same time, but that's okay. I'm going to place this one out here and show you what happens. Yeah, see? Very important to place that note inside of the border so it likes to travel with. Okay. Now, we've located our holes, we've called out our holes. Everybody's happy. Hopefully last, is coming to this right view. The only thing left that is not dimensioned is the depth, which we could have done here. We'll see. And then this pocket. All right, so let's dimension this pocket. Now this is just a weight reduction feature, right? So not too worried about 3 decimal places or anything like that. So we'll just say, you know what, make this thing a 2.5 by 1 inch pocket with again a standard fillet in the corner. We can say that is typical. Okay, because that's all we see in that view. And We put a center line in this here. All right. Now, you would think that covers everything. We have one problem. We have the depth of this pocket. See it here, we can see it there, but we cannot really see it. We don't have visible edges to rely on. We really actually need a section view. Nice. What's that going to cause us to have to do? We need to make room for it. So let's push this guy out of our way for a moment. Maybe he'll hang out down there for a moment. And I want a section view across that. Do it. We don't have enough room left really to do one out to the side here. That's why I moved that isometric. So maybe we can grab this space up here. All right. So let's go to section view and let's get the midpoint. Okay, we want one that sections across that way, and we want the midpoint in this cut because that's what we want to see. And we can flip the direction because it really is not going to matter. That view is still huge, but maybe we will trim it down. I've never tried trimming or creating a break view. Of a section view, but you know what? Looks like it works. That makes it fit on the page. So, because all I really needed to show in this was the depth of the cut, right? So annotation, let's get that depth of the cut. Again, it is just a weight reduction, so I'm not going to get fancy. And we will say typical. 1, 2, 3. All right. There we go. We've got everything detailed now. Be really nice if we could fit our isometric back up there in the corner where it belongs, but luckily we've kind of made this space down here in our title block scenario, and we could shrink this if we needed to. I think we're okay though. I think we can get away with this. Okay, so there we go. We've detailed out everything. I may have missed something. That's why it's nice to have somebody to back you up and look over your stuff, so you never know what you might miss. We got to create a section view. We even got to play with creating a break view. We overlaid a break view on a section view. Hope we didn't violate any rules there. I don't exactly have the ANSI standard here in front of me to check everything, but I think we'll survive that one. And if not, we can always move up to a B-size drawing and we can fit all this stuff no problem. So B-size sheet. So anyway, if you have any questions, comments, let me know. Otherwise, I hope you have a great day, afternoon, enjoying playing with SolidWorks. And again, let me know if I can help. Send me a note, comment. Take care.